Hi Maddie, so we'll go over questions 4 and 9. So this one says, sand falls from a conveyor belt at a rate of 10 meters cubed per minute onto the top of a conical pile. Okay, so it's making a cone. And this value that they're giving you, the 10 meters cubed, that's adding to the volume. So that's your dV dt. Okay, now we want to know how fast the height and the radius is changing. So how fast the height is changing, that's going to be dh dt, the rate of the height. And how fast the radius is changing, that's going to be dr dt. So we're kind of going to do this problem twice. Okay, so we're going to start with the height. So I gave you that the volume of a cone is 1/3 pi r squared h. Now we're also told in this problem that the height of the pile is always 3/8 the base of the diameter. So kind of off the side, we're going to say height is always 3/8 diameter. Now diameter is equal to 2r, so we're going to plug that in. 2 times the radius. So just simplifying, if we cancel out that 2 with one of these 4s, we'd have h is 3/4 r. Now we want to solve for dh dt here, so we actually want everything in terms of h. So we're going to solve for r here. We're going to multiply both sides by 4/3. So we're going to have 4/3 h equals r. So that's what we're going to plug in for r here. So we'll have v equals 1/3 pi 4/3 h squared times h. So v equals 1/3 pi 16/9 h squared. I have to square the 4/3 and the h times h. So before I even take a derivative, I'm going to simplify this even more. I can multiply the 1/3 times the 16/9. So v equals 16/27 pi, and then h squared times h is h cubed. So now taking our derivative, on the left-hand side we'd have dv dt equals 3 times 16/27 pi h squared dh dt. Okay, so dh dt is what we're looking for. So for the dv dt, we're going to plug in 10. And we have 3 16/27 pi. And for h, it says when the height is 2 meters high. So we'll plug in 2 for h. Now, I don't have a calculator with me right now, so I'll let you solve for dh dt from there, but it would just be dividing both sides by 3 times 16/27 times pi times 4. So just note that pi is not under the fraction, it's on the outside. Now, it's going to be very similar when we're solving for dr dt. So we're still going to have this v equals 1/3 pi r squared h, but instead of plugging in for r, we're going to plug in for h. Sorry, I started to do an update. So we know h is 3/4 r, so for h, we're going to plug in 3/4 r. Okay, so here we can multiply the 1/3 times the 3/4. The 3's would cancel out. We'd get 1/4 pi r cubed. So now when we take the derivative of both sides, we'd have dv dt equals 3 times 1/4, so 3/4 pi r squared dr dt. Okay, so we're still going to plug in 10 for dv dt. Then we'll plug in, now we still know that the height is 2. So to find what the r is in this case, I'm going to come up here. We have this little formula that 4/3. We have this little formula at 4/3 h equals r. So we would plug 2 in for h there. So we'd have 8/3 equals r. So we'd have 8/3 squared dr dt. And again, from there, you would divide both sides, you would solve for dr dt. Okay? So let's go on to number 9. And there are really two ways you can approach this problem, so I'll show you both of them, but you would only need to do one of them. So the first way is to use the chain rule. And using the chain rule, so here's our original function. Negative cosine of x over 1 plus sine of x squared. So for the chain rule, so we'd bring the 2 down, and then we would leave what's in here alone. So we'd leave that alone. This would become to the first power. Now we need to multiply by the derivative of that inside stuff. And to do that, we need to do the quotient rule. So that's probably not going to be enough room. So we'd have low, so 1 plus sine of x times d high, which would be the derivative of negative cosine of x, which, since the derivative of cosine is negative sine of x, it would be a negative sine of x, so it would just be sine of x. Low d high minus high, so negative cosine of x, d low, which the derivative of 1 is 0. The derivative of sine of x is cosine of x, all over low squared. Now, to simplify this just a little bit, and I mean, if you put this answer in on MathXL, I would totally count it as correct and give you the points, but just so you can kind of see how they got what they had. So we have 2 negative cosine of x over 1 plus sine of x. So up here, first we're going to distribute the sine of x. So we'd have sine of x plus sine squared of x. And then this negative would become positive, so plus cosine of x. So cosine squared of x. All over 1 plus sine of x squared. Now, sine squared of x plus cosine squared of x, that was an identity we learned last year. That's equal to 1. So here we'd have 2 times negative cosine of x, 1 plus sine of x, sine of x, plus 1 over 1 plus sine of x squared. Now, it doesn't matter where you cancel out, but we could cancel out this sine of x plus 1 with this one or one of those, and we could just write this as negative 2 cosine of x over 1 plus sine of x squared. Now, the other way, let me just bring this down with us. Okay, so the other way we could do this problem, so let's write this as y equals negative cosine of x over 1 plus sine of x squared, is we could use logarithmic differentiation. So we could do natural log of y equals natural log of this. So natural log of y, we'd bring the 2 down in front, and then we'd be subtracting these, and we'd have to distribute the 2, so the 2 would go with each factor. So we'd have 2 natural log of negative cosine of x minus 2 natural log of 1 plus sine of x. So on the left-hand side, we get 1 over y dy dx. So on this side, so we'd have 2, and then derivative of natural log is 1 over x, so we'd get 1 over negative cosine of x. And then we'd need to multiply by the derivative of negative cosine of x, which, as we've talked about, is just positive sine of x, because the negatives would cancel out. So we'd have sine of x. And then minus 2, we'd have 1 over 1 plus sine of x. But then times the derivative of this, which would be cosine of x. Okay. Then the last step, we would want to multiply both sides by y, so we'd get, dy dx. Sorry, my pen keeps cutting in and out. dy dx. Well, let me just say it since my pen won't work. So you'd have y times all of the stuff on the right-hand side, and for y you would plug in the original equation. But you were kind of on the right track when you were starting it with using the chain rule, but you didn't leave the original stuff in there, which you should, and then you need to use quotient rule when you multiply by the derivative of the inside.